If you have an Android phone and you're using WhatsApp, please don't accept any HTML files that are sent to you as attachments. Several vulnerabilities have been found on WhatsApp, and they are scary. Man in the middle, man in the disk, essentially exposing and reading the entire content of your SD card. So if you have images, attackers can easily, with a single opening of that HTML file, they can read all that stuff. So let's jump into this article and discuss. And it looks like this attack does not affect WhatsApp on iPhone, but that remain to be seen. How about we jump into it? Welcome to the Backend Engineering Show with your host Hussein Nasser, and today we have a beautifully written article by CENSUS, the IT security works. This is an extremely detailed article that goes into the weeds of how this attack happens and how you can implement it. There's so many references on the end. So I'm gonna essentially summarize part of the attack, then goes into the interesting portions of this article and read it below for you guys. And essentially I'm gonna reference this article for you guys if you're interested to read and learn more about it. But the exploitation happened here specifically on WhatsApp, and specifically on WhatsApp on Android. As far as we know, iPhones are not affected because they don't have these particular vulnerabilities that we're about to discuss. Again, it's worth mentioning, this is only affecting Android, I believe, version 9 and older. Android 10 and above doesn't have this problem because all these bugs have been fixed on both WhatsApp, and the Android version has essentially, the new Android version started forcing certain things that we're going to talk about to kind of prevent this vulnerability altogether. All right, so what's the attack? Remote exploitation of man in the disk vulnerability in WhatsApp. So we know what man in the middle. The idea of having an attacker intercept network activities and then terminate TLS, serve you their own certificates, or somehow authenticating themselves, tricking you to authenticate themselves, and tricking you to have a complete deciphered text between you as a client and the server. Very bad. Man in the disk, as far as we know, this is something I just learned actually today while reading this article. Man in the disk is essentially an attacker sitting between you, the client, they're using your phone, and the disk, which is the external storage, and Android. And they essentially can read and write between anything that goes into your storage and out of your storage. So they can read stuff between your SD card and the application itself that is running. Right? In this particular case, it's WhatsApp. So now that we know this part, what exactly is going on? So here's a quick summary of this. The attacker will send you an HTML file to the victim through WhatsApp. The victim will open the HTML file, and obviously, since the HTML file will be opened, it will need a browser to open it with. And the browser will be Chrome or any other browser in the device. That is Android in this case. When Chrome opens that HTML file, the HTML file essentially tries to read through the SD card, and it's doing that through a URL, through the scheme that's called content, essentially. That's called content / SD card / WhatsApp1.jpg, read a JPEG pic. It will take that content and send an AJAX request, basically using a fetch or XML HTTP request to the attacker server. So just like that, they are able to read that. And other variation of this attack is they're also reading the TLS session keys, the pre-computed keys for session resumption. Now they're reading that. They can even read that and can do a man in the middle. So using the man in the disk, which is we just described, reading through the disk information, they can essentially perform a man in the middle by reading the session keys and do a man in the middle attack. So given that these keys are stored in disk. So we're going to go through all of that now in a minute, because there's a lot of questions now popping in your head. It's like, how can we just randomly read through disk? That's not possible. Well, that's a bug, essentially, I believe in Chrome, maybe, right? Through the content security policy, right? If you're opening an HTML file through like file / or content / you can't really read something else, right? We prevent you from CSP, right? Or single origin policies. You cannot read something else. This is very secure, but there is a vulnerability that this was bypassed, and an attacker opening an HTML file on the victim machine can read something outside their origin, in this case, the whatever space Chrome allocated for it, for WhatsApp. All right, so let's read through this part. The Android Media Store Content Provider. When a user clicks on a pictured message, WhatsApp needs to call an external application to view the file. In this case, is Chrome in the case of HTML, the image viewer in the case of image, and so on. However, the external application might not have access to WhatsApp internal storage. Indeed, one cannot make any assumption on the whereabouts of this picture file on the file system or its permission. So in the pictures case, there must be a way for the photo viewer to locate, read, and display media files belonging to WhatsApp. Enter the concept of content providers that I just explained, right? The content scheme, essentially. An IPC mechanism by which one application, example WhatsApp, can share resources with another application, Google Photos, or Chrome in our case that I explained. Content providers are an interesting technology and powerful tool in the hands of Android developers. There are plenty of content providers on an Android system, some expected by third-party applications, others exported by Android framework itself. For example, a modern Android device comes with a content providers that exposes SMS, MMS, telephony logs, browsers, bookmark, downloaded files, and so on. Of course, content providers also come with means of controlling access to their resources. Like, of course, you can't just access every single app and every single content. So there is some sort of permissions here. However, they are not free of vulnerabilities, and that's where it happens here. For people listening on the podcast, we're looking at how you can query external files on SD disk by providing content :/media/external/file. And you can provide -- projection to actually display that file locally in the app that you actually opened it with. So content // this is something we don't usually use. It's apparently is a scheme specific just for Android, and Chrome supports it. And there's where it can go nasty. So now we know content. We go jump into, and here they shows the actual every details about how you can implement this yourself and stuff like that, right? So now, if you can read content through any place in SD card, right? That is absolutely dangerous. And that's what the problem here remains, right? Because you can read through SSL sessions, you can read through anything that WhatsApp gives you access to, essentially, right? That's what's happening here. Okay, so if you have stored WhatsApp images, WhatsApp other stuff as well, so the content scheme give you access to these SSL, TLS sessions, session tickets, pre-shared keys, pretty much all of that stuff. Now, I'm not sure if this app will give you full access to pretty much everything that is in the SD card itself. That remains to be seen. Of course, I think there is some sort of a limitation here. But still, access to WhatsApp is pretty much... there's a lot of stuff in WhatsApp, right? So like images, voice notes, imagine having access to that. Just that's a lot, right? So here's another thing that allows this to actually happen. Chrome CVE 2020-6516, same origin policy bypass. I talked about this in another video right here if you're interested to learn more about it. Chrome has this bug that bypasses same origin, right? That means if you are in https example.com and you want to go to you want to load a JavaScript file from attacker.com, you can't do that by default. You have to be allowed by the source, by the origin, to access other sites, right? That's the content security policy. By default, there is the same origin. You are only allowed to access the same origin. If you loaded example.com, you can only load example.com/css index.html or style.css from the same domain. This can be bypassed by certain course policy and stuff like that. We talked about that many times in the channel. If you want to learn more, I'm going to reference the videos right here. So there's a bug that allows someone to read the content from the external file and turn around and send a post request with the content that they just read in the HTML file to the attacker website. So if I have an attacker website, hosted stuff, and I can upload stuff to it, I can send you the HTML file, which has JavaScript, to read the content /media/external/file/hello.jpg and in your WhatsApp, and then read that and then turn around and send it around to my as an attacker website. And I can do this in all with a single HTML file. Very scary. They're showing how to read a file in the media store, essentially, right? And that's the problem here. Chrome does not prevent you from reading other paths. And this is where you can pretty much read anything, even outside WhatsApp, given permission to you. Nixie. So one might ask, but how is WhatsApp related to this Chrome vulnerability? If an attacker sends a malicious HTML file to a victim user over WhatsApp, then when this file is viewed, it will actually be rendered using Chrome. Chrome will use a content provider internal to WhatsApp to access the malicious JavaScript content. However, due to CVE 2020-6516 Chrome bug, the malicious code will be able to access any other resources from any other content provider on the system. The astute reader might remember that we have found that WhatsApp placed SSL session cache and the WhatsApp TLS sessions directories under unprotected external storage. These directories contain TLS session cryptography material. Yikesy. The material could have been collected in a way we just explained by remote attackers through a phishing attack. So now they're going through now we saw how we can read JPEG and voice notes from WhatsApp and send it to an attacker easily, right? Here they show that, okay, now we're going to go even more serious than that. I want to read your text. How can I read your text? Session resumption and pre-shared keys in TLS 1.3. In order to do that, we need to understand WhatsApp is an end-to-end encrypted. So that means there is a TLS session between you, the client, and the server, and there is another end-to-end session, TLS session between you and the user that you want to communicate with. So your messages is actually encrypted end-to-end. So how would someone use this kind of attack, the HTML file sending attack, the disk man in the disk in the man, I forgot what it's called, and read TLS session keys in order to decrypt the traffic? Well, let's think about this a little bit. TLS 1.3 doesn't really store anything because it's everything in the memory. We establish the handshake between client and server to establish the key exchange, give you back a key, and that's it. Now you have a key between the server and that. And every time you send information, you use the pre-master key that you computed, and you calculate obviously a symmetric key, and then you calculate everything with this symmetric key. And they don't store the symmetric key on disk. They don't, because it's ephemeral. We never store this stuff. However, there's something called session resumption. This exists both in TLS 1.3 and 1.2. And I'm going to skip through this to simplify this video, right? Essentially, the idea here is to do 0 RTT round trip in 1.3 and essentially cut 1 round trip in 1.2. It's like, okay, hey, we did talk about with each other, right? You know me. I'm still same OG, but I've been low key, right? So, and then the client will say, okay, we did communicate before. So here's a pre-shared key from previous session that we talked about. Let's just, here's some data. Let's just resume that session. In order to do that, you need to persist that key somewhere in disk. On disk. Is it on or in disk? I don't know English. All right. So you store it on disk, and then you will have these, and you will use this PSK, the pre-shared keys, to whenever you want to resume, you can just set that. You save a lot of CPU power, right? And if you're using RSA with your certificate, you don't need to authenticate the certificate anymore, which is kind of a double-edged sword because, yeah, certificate authentication is expensive, but it's required to know who am I talking to. But when you use PSK, which is the session resumption, you don't need to authenticate because, hey, I know you. Let's just reconnect again. And that's the problem here. And here's what you can use. You can read those session keys, which is stored in plain text, really. WhatsApp just stores them right through it. And then you can just read them and use them as a man-in-the-middle attack. Scary stuff. Obviously, they go through details here showing you how to do it in 1.3, how to do it in 1.2. This is a well-written article. Very, very, very well-written articles. Kudos to everything. They show you how the code works, every single thing. Very scary stuff. So yeah, they can read your images, your voice notes, anything that you sent and saved on your SD card, right? The external SD card. And they can even read the keys required for this noise key protocol, which is used for end-to-end encryption. That means they can see your messages if they deployed a successful man-in-the-middle attack, which we know it's not really easy. They have to be in the way of the communication. So either they have to be your router or a shady router, a shady ARP poisoned machine in a Starbucks cafe, right? So that traffic flows through them to essentially perform a successful man-in-the-middle attack, or maybe your ISP, obviously. Anything that is in the root, right? If that is not in the root, they cannot do this stuff. Let's read through this. Let's watch this video. All right, so let's pause this. So on the left, this is the attacker WhatsApp control panel, and it's being controlled with a Python script that sends this stuff, right? So let's go ahead and watch it. What does it do? So obviously, hey dude, it says, hey dude, check this interesting article. Shady as F. So all right, we're going through this here, sending this message. All right, so going through the script here, you can see that this is what he did. And now the script is sending compiling an HTML file, sending the HTML file. The victim received the HTML file, obviously. The victim will open the HTML file in a minute, any second now. Uses Chrome to open the file, and that's when the script, that is the inline script in the HTML file, executes, reads all that stuff, and tries just to read every single file that it can read through that content. Obviously it says com.whatsapp.provider.media, reads everything, and obviously just go ahead and uploads it to the server, to the machine. Says and say, hey, we're receiving. The attacker is actually listening on a server, because it's Python, listening on a server and accepting these a post request for this uploaded attachment. And here we go. I received the sessions, received the files, and play. You list all that stuff, and here you go. All the bin folders. Essentially, these are probably compressed files of everything. Yeah, scary stuff, guys. So in general, Android, I believe 11, if I'm not mistaken, they came up with this idea of scope storage, so that you don't really have access to everything. Every application will have a narrow access to only what is supposed to access. Right? That's what I understood from. I don't use Android, but anyone who user of Android, give us more information about that. That would be awesome. Essentially, that scopes it. So yeah, even if you want to read it, you can only read the stuff that you're supposed to read. Content security policy and then content same origin is blocked now. You cannot just go ahead and read stuff that you're not supposed to read. And obviously other vulnerabilities, any other patches that WhatsApp can do, it is actually doing. All right, guys, update your WhatsApp. I guess, update to Android to the latest version as fast as possible. I know not every person can do that, but these are really, really dangerous stuff. Simplest thing is just don't open HTML files. You can open links, right? Even links really is just dangerous, but not as dangerous as actually opening HTML file, which runs on your disk, which are giving different permissions compared to URLs that, oh, you're going to example.com. You can only do so much. Yeah, you can do harm with a URL, but not as much as running a file locally with a context of disk where it can read stuff, right? Outside, you go example.com, you cannot just go and read content, right? You will be blocked with the content security policy for sure, right? But that's the bug here, right? All right, guys, that's it for me today. I'm gonna see you on the next one. You guys stay awesome. Goodbye.